Hey guys, in this video we're going to look at multiplying and dividing rational expressions. Now there's a few things I'm going to add to what you've already seen in your lecture video, so just make some extra notes. If you are not watching this video, obviously you wouldn't know this, but we will talk about this in class as well. So for our first example, let's look at 2x minus 3 divided by 5x multiplied by 5x plus 5 over 2x squared minus x minus 3. Our first step, we want to factor everything. So in our numerator, 2x minus 3, we can't factor. 5x, we won't factor. But in the second numerator, we can factor out a GCF of 5. So it's 5 times x plus 1. And in the denominator, this will factor to 2x minus 3 and x plus 1. Now, I'm going to go through the factoring process or the factoring portion of these problems very quickly. I encourage you guys to stop, and I'll try to remember to remind you guys to pause the video, go through the factoring techniques that you guys are practicing right now and that you've already watched in the videos, and make sure that your factors match mine. So now that we have our terms factored, we're going to state our restrictions. This is something new that we may not have seen in your original lecture video. I want to make sure that you guys are consistently stating restrictions no matter what type of rational expression problem you're dealing with. So looking across the denominator, our restrictions are x cannot equal, let me try it in red, x cannot equal from this one, 0 from this one. Where does this factor equal 0? That's at 3 over 2, and this one is at -1. Again, guys, you practice finding domain, and that's what stating restrictions are. All we're doing is setting each of our factors equal to 0. Now that we've stated all our restrictions, now we're going through and we are canceling out like factors. So this factor of 2x minus 3 cancels out with this factor of 2x minus 3. This 5 cancels out with this factor of 5. And this x plus 1 cancels out with that factor of x plus 1. Now that we've simplified everything, we multiply across. If you look at our numerator, it doesn't look like there's anything left. But remember that we can always add a factor of 1. So that's what's remaining in our numerator, 1. And in our denominator, we have x. Let's try another one. X cubed plus 27 divided by negative 2x minus 6 times 4x cubed divided by x squared minus 3x plus 9. Again, we're going to start by factoring everything. Factor all your numerators, all of your denominators. So go ahead and pause this video now, factor, and then come back and check your factors with mine. So if you're back, check your factors. The numerator factors to x plus 3 times x squared minus 3x plus 9. We recognize that x squared plus 27 as a sum of 2 cubes. From this first denominator, we can factor out a -2. 4x cubed is already a monomial. We won't factor it any further. And x squared minus 3x plus 9, if you tried to factor it, you found that it would not factor. So now we want to go ahead and state our restrictions. Looking across the denominator, we have 1, 2, 3 distinct factors that we want to find where they equal 0. From this first one, -2 is never going to equal 0, so there's no restriction there. X plus 3 equals 0 when x equals -3. And this x squared minus 3x plus 9. At this stage in the game, when you guys have a trinomial that's in the denominator, if it doesn't factor, it's not going to present any restrictions. But that's just for right now because we haven't gotten far enough to show you guys what you can do to find the zeros when it doesn't factor. Okay, so keep in mind, eventually down the road, yes, we will be able to possibly solve those trinomials even if they don't factor. But for right now, if you can't factor it, then it doesn't provide a restriction. So we have all of our restrictions. We only had one in this case. Now we go through and we start simplifying like factors in the numerator and the denominator. Moving across from left to right in my numerator, x plus 3 and this x plus 3 cancel out. X squared minus 3x plus 9 and this x squared minus 3x plus 9 cancel each other out. 4 and negative 2. What's 4 divided by negative 2? That's negative 2. And all I've left with is an x cubed, which there is no factor of x in the denominator to simplify. Multiplying across, I have negative 2x cubed, and there's nothing left in the denominator. So this is my expression simplified. Notice I still keep all of my original restrictions. That restriction of x equals negative 3 still exists in this final answer, even if there isn't a denominator anymore. Let's practice dividing rational expressions now. 12y cubed divided by 5y squared minus 5 divided by 6 over 1 minus y. Start the same way. With multiplying, we want to factor everything. 12y cubed is not going to factor. 5y squared minus 5, we can factor out the 5. Y squared minus 1 divided by 6 over 1 minus y. That's that expression we saw in the last video. We want to change the order. We want the y to come first. In order to do that, we have to factor out the negative 1. If you guys don't remember that, I encourage you to go back and watch the video for simplifying rational expressions. You'll see a few examples with that exact same type of problem worked out. Now we want to state our restrictions. Oh, before we do that, we can factor this further. So 12y cubed divided by 5. Y squared minus 1 is that difference of two squares. Y plus 1, y minus 1. And now that everything is completely factored, we'll start stating restrictions. Going across the denominator, 5 is not going to provide a restriction. Y plus 1 is negative 1, and I should actually make this a y, not an x. Let me fix that. Y cannot equal negative 1. From this factor, y cannot equal positive 1. And from here, we have the same factor of positive 1. We don't need to restate it. Now that we've stated our restrictions, now we do the keep, change, flip that we learned on how to divide fractions. We keep the first fraction, 12y cubed, divided by 5 times y plus 1, y minus 1. We change from division to multiplication, and then we're going to flip that second fraction. So the second fraction is now negative y minus 1 over 6. At this point, we want to check to see if we have any new restrictions from this new denominator. Because our new denominator is 6, there are no additional restrictions. And now we have a multiplication problem. We just did 2 examples like that. We want to cancel out like factors in the top and the bottom. So we've got this y minus 1 and this y minus 1. 12 divided by 6 is 2. And this y cubed, there is no factor of y in the denominator, so that's not going to simplify with anything. We multiply across. We have 2y cubed and a negative 1. Multiplying, that gives me negative 2y cubed. In the denominator, we have 5 times y plus 1. And we still have our original restrictions, negative 1 and 1. For your final answer, it's completely acceptable for you to leave it factored like we have in the denominator, 5 times y plus 1. You do not need to distribute that 5 if you don't want to. Let's try one more. This is a really great exercise to practice your factoring. So again, go ahead and press pause. I want you to factor all 4 of these trinomials. They all have lead coefficients of a value greater than 1, or different than 1 rather. So you might be implementing that AC method quite a bit. So go ahead and press pause and then come back and check your factors with mine. All right, if you're coming back, go ahead and check your factors. We have 4x plus 1 times 2x plus 3 divided by 4x plus 1 times 5x minus 1 divided by 2x plus 3 times x plus 2 over 5x minus 1 times 7x plus 2. Now that everything is factored, we want to state our restrictions. What can x not equal? Looking across the denominator, we've got 4 factors that we would set equal to 0 to find our restrictions. From this first one, x cannot equal negative 1/4. From the second one, x cannot equal positive 1/5. From this third factor, since it's the same as this one, we don't have a new restriction. And from this last one, 7x plus 2, we get negative 2/7. After we state our restrictions, then we apply keep, change, flip. Applying the keep, change, flip transfers this problem into a multiplication problem. But now we start from the very beginning of those steps for solving or simplifying while multiplying rational expressions, which include factoring. That's done, but stating restrictions. Just like in the last one, once I flipped this second fraction, we wanted to check for new restrictions. Going across, we still have the original 2 from our first fraction, but now we've got a denominator of 2x plus 3. Well, that results in a restriction of negative 3/2, so I add that to my list. And this x plus 2 is 0 when x equals negative 2. So I've just added 2 new restrictions to my list of total restrictions. Now that we've stated all of our restrictions, we can cancel out like factors in the numerator and the denominator. We've got 4x plus 1, 4x plus 1, 2x plus 3, 2x plus 3, 5x minus 1, 5x minus 1, and the 7x plus 2 doesn't have a like factor. So this whole big mess of a problem simplifies to 7x plus 2 divided by x plus 2. So a big messy problem can be written and expressed as this nice simple rational expression. And that's the point of simplifying. That's why we want to do that, because when I'm evaluating an expression, it's much easier to evaluate what we have in this box versus what's up here in the very beginning. X plus 3 squared divided by x squared minus 9 times 2x minus 6 over 5x divided by x squared plus 7x plus 12. Anytime we're dealing with multiplying or dividing rational expressions, we want to start by factoring everything. This first numerator is already factored, but I'm going to express that power of 2, writing the binomial twice. X plus 3 times x plus 3. X squared minus 9, that's my difference of squares. X plus 3 times x minus 3 times 2 times x minus 3 over 5x divided by x plus 3, x plus 4 over x. So stating our restrictions, x cannot equal negative 3, positive 3, from this middle one 0, and down here is 0 again. Now we've still got one division here, so we want to do the keep, change, flip to change that from division to multiplication. But we're going to keep all the original, or the first 2 fractions, x plus 3, x plus 3 over x plus 3x minus 3 times 2 parentheses x minus 3 over 5x. Change from division to multiplication, and now we're flipping that second fraction, or that last fraction, excuse me, x over x plus 3 times x plus 4. Because we have a new denominator, we want to check to see if we have any new restrictions that we need to add to our list. From this one, we've got negative 3, which we've already listed, But now we can also include -4. So we have that one new restriction added after we flipped that last fraction. Now that all of these rational expressions are being multiplied, we can simplify any like terms that are in, or like factors that are in the numerator and denominator. X plus 3, x plus 3. X plus 3, x plus 3. 2, I have a 5, but 2 and 5 won't simplify. X minus 3, x minus 3. This x and this x will simplify out. Multiplying across, what are we left with? We've got 2 in the numerator divided by 5 times x plus 4 as our final answer, and we keep all of the original restrictions that we found along the way. So just to recap, when we're multiplying and dividing rational expressions, we always want to start by factoring everything, stating restrictions. That requires just looking across the denominator. My phone is ringing. That's funny. Looking across the denominator and finding what values of x make any of the factors in the denominator 0. Once we've stated our restrictions, if it's a multiplication problem, we're just simplifying out like factors. If it's a division problem, then we're doing the keep, change, flip, where we change from division to multiplication and we flip the last fraction. And then it's a multiplication problem, and then we simplify like factors. The key that we want to remember when it comes to restrictions is that we keep all of the original restrictions. Any restriction that we got along the way, we keep it as part of our final answer. So we'll talk to you guys next time. Have a great day. Thank you.